Hi everyone, I'm Mark Juggurnauth-Thomas. I'm a software engineer on the source control team at Meta in London. I've actually been working on source control adjacent stuff on and off for about 23, 24 years now, so I've been doing this for a while. But for the last 8 years, I've been at Meta doing source control there. So we use a giant monorepo, as a lot of other large companies use as well, so that comes with some of its own unique challenges, and that's what I'm here to talk to you about today. Obviously, some of you are probably aware we don't use Git for our large monorepo. We use Sapling, which is based on Mercurial. But the things I'm going to be talking about today are sort of general principles. It's more about sort of usability of source control. And we do have an interest in Git. Like we do use Git for a bunch of repos, and Sapling itself is now Git compatible, so it can talk to Git repos. So Git is relevant for this as well. So in terms of what am I talking about when I'm saying about branching in a monorepo? So if you were here or in Berlin last year for the Git merge conference, in the unconference portion of the talks, we had a section about branching in monorepos. And we were asking the question there of, like, how do you reconcile having a monorepo where everybody's all working together with the need of some of the teams in the company to manage multiple concurrent branches of code? And so to step back a little bit, let's think about what a monorepo actually is. We're talking, it's not just about having one big repo. There's some details about how you actually use it as well. So when you have a monorepo, you typically have a single branch, like a main branch, which has the latest version of all of the code. And you will want to have try and maintain a linear history, so you don't use merges, you just rebase things onto the main branch. And everyone moves forward together. And this works great if you're doing something... let's carry on. So yeah, with the point of the monorepo is everyone moves together. So this works well if you've got if you're developing a website, something like that, where you have kind of a latest deployment of the website. Everyone's using the latest code. But it starts to become more limiting when you have things where you actually want to have multiple versions. You want to have like a development branch or a release branch, or you want to have branches that are kind of old copies of code that you're maintaining whilst developing new things. And so obviously you can branch a monorepo. Like there's the tools like Git and Sapling. You can just create a branch and you can and use a separate branch there. But the problem with that is everything is branched. When you branch the monorepo, you branch the world. So that's fine if the branch doesn't live for very long. But if you want to have a long-lived branch, then all of the other things in the monorepo that your team isn't working on will start to decay. Like if you've got some other team changes their API for their service, then you won't get their client-side update, and so your branch will stop working. And also, because we're trying to maintain a linear history, if you do go off and make a branch and make some changes there, you can't really merge that back in to the main branch. So at Meta, we don't allow merges in the monorepo simply because of performance, but also it's really confusing to be able to do that. So you don't have those merges. So how are you going to use branches here? What do you actually really want to do? So what the goal is, what you want to have is you want to have multiple branches of code. So you want to have maybe development versus stable. You want to freeze a copy. You want people to be able to collaborate on all those different branches. So you want to be able to work on any branch. You want to be able to cherry pick changes, merge branches together. That's the kind of set of features you would have if you were using a smaller repo, and you would use them, use the branch operations that a tool like Git or Sapling provides. And then the other sort of aspect of this is kind of a problem anyway, even if you're using multiple repos, is you need to have some way of controlling your dependencies. One of the advantages of a monorepo is that you don't have this problem, right? If you've got lots of small repos, then you need to have another layer of tooling that controls like which branch of which thing you're using, which version of things you're using, probably built into your CI pipeline. But with a monorepo, that goes away. But now if you're bringing branching back into a monorepo, you have that problem again, and you need to solve it. You need to choose when your changes that you make actually affect things that are depending on you. So these are all things that we want to have. So basically, to summarize it, what we want to do is we want to have the benefits of branches while retaining all the benefits of a monorepo. We want to have our cake and eat it, really. And yeah, we also want a working display. Is there something I need to do to make this start again? Cool. not sure how to follow that. Okay. Cake. I was talking about cake. We want to have our cake and eat it. We want to be having the benefits of branches while retaining the benefits of the monorepo. So, as I said, last year at the Git Merge Unconference, we asked this question, and there were various ideas thrown about the room. We very deliberately didn't prime the audience with the thing we were planning to do, because we wanted to see what other ideas people had. But what we were planning to do kind of came up anyway, and that is the idea of sort of vendoring yourself, like making how you have vendor directories in monorepos quite often. Can you vendor yourself to create to sort of act like you're doing branches? So we call this directory branching. And it's basically that exact idea where you treat branches like directories. So you keep copies of code in separate directories. And so you still have a monorepo, you still have everything that you're doing in a normal monorepo setup, but you just accept the fact that you've got multiple copies of code in directories next to each other. And what we found was when we started implementing this is a bunch of teams at Meta were already doing this. Like where they had this need, they'd kind of made the decision themselves. They'd made multiple copies of their code, checked them in, and then they were just manually copying code around and changing imports and things like that, or writing scripts to do this. So the tooling was, they were making their own tooling because the tooling as it was didn't really support what they needed. So we decided that the thing to do is uplift the tooling to support the workflow that people were already using and the one that people wanted to do, that engineers wanted to use. So we added metadata and improved the sapling tooling to make this approach work well. So we wanted to make it so that you can have a directory branch, but then you can do things you would normally do on a branch to that directory. So to give an example, there's a bunch of things you can do with this. I'm going to give a worked example of one particular workflow, which is a very common pattern where you have two branches, dev, where you do your development, and then stable, where you push releases to periodically once you've tested things and you're happy you've got a stable version of your code. And so if you look at this visualization of the repo, you have a directory, which is the dev copy of your code. And then with directory branching, when you're ready to create your first stable branch, you use the subtree copy command to say, I want to copy this particular revision from this particular path to this other path. And this is essentially the same as just doing a copy and adding the files and committing them. But we add one extra bit of metadata, which is that orange arrow there to say this directory is a copy of this other directory from this other commit. And then the sapling tooling understands that metadata and maintains history across that edge. So if you run blame or log in the stable directory, you get the history going back into the dev branch history. You also have the fact that because now these branches are side by side, you can see both of them, you can compare them, you can work on them as you would want to. So that's not all. Obviously, you've made your stable branch, but now maybe you've got a bug on your in your code, and maybe it's a security bug, and you need to fix it quickly on the stable branch. So you write the fix in the dev branch and test it there, but then you want to cherry pick it into the stable branch. So we've got the subtree. Graft is sapling's word for cherry pick. It's exactly the same operation. It just uses a different verb. You do graft from this directory to this other directory, and it will create a new commit with the changes in the other directory automatically remapped onto the new directory. And because of that extra metadata, all of the copy tracing, conflict resolution stuff that exists for a normal cherry pick operation also works across directories. So that's cherry pick. And then further to that, if you want to start merging things together, like when you want to do your actual next release, we have the ability to do a subtree merge. So you can say merge this directory from this other path to this other path. And that will create a ordinary commit. This is not a merge commit. This is just an ordinary linear commit. But the changes in the stable directory are everything that's needed to catch up from the dev directory. And again, we store some metadata to say that this happened. And now that means that all the conflict resolution stuff that you would expect from a merge still works. Log and blame on files in that directory still work. They recognize the difference between the two branches, and they will take you to the correct commit if you're looking at those files. But because this is a monorepo, our main commit graph, the main sort of view that everyone else has, stays linear. This is just an ordinary commit. So we implemented that in Sapling, but then we sort of discovered that there are some other things as well. Like, it's not just about source control. Like, isn't sufficient to just build this into the source control tooling. We need to support the other tooling in the developer infrastructure as well. So we implemented support in our build and CI system. So that allows you to, when you're working on code that depends on something that's been branched in directories, you can select which branch is being used. So we use bucket meta, so we use buck config modifiers, so you can set a config modifier to say, I want to use this particular directory branch of this library in this build. And for CI, you can set configuration to say, I want to test this program. I want to run this test against both this branch and this other branch because I want to see, I want to see if this will break, and the next time the dev branch is released to stable, for example. Our code review tooling, we also added support there, mostly just to highlight that these things have happened. Like, the subtree copy is a really good example. If you take a copy of a directory that's got 1,000 files in it and you just make a new commit that has those same files copied, and then you put that up for code review, your reviewer just sees, Mark added 1,000 files, and they're not going to actually review it. They're probably just going to click, oh yeah, sure, accept. What we do for subtree copy operations is we actually compare against the copy source. So we'll show the code. We'll say in the code review, Mark copied this directory from dev to stable, and these are the additional changes that he made on top. And so you can actually review that properly rather than having to just see a whole load of files added. And then finally, the last thing we're still working on this one, is code search. Like, the problem with having multiple copies of code, and again, this is already a problem, especially with vendoring, is if you search for something in your code base, your code search tooling will yield duplicate results across all of the different things. And so what we are working on is some way to prefer a particular directory and say, say that a particular directory is the main directory for this thing, and then deduplicate things in the code search tooling. We don't really want to have it so that people have to explicitly say that they created these copies, because people will forget to do that. So we're trying to build it so that we build an index so that we recognize when these copies operations happen and remember that fact automatically. And so the final part of this is actually going back full circle to the idea of vendoring. So now that we've got these tools that let us do subtree operations within the monorepo, can we make vendoring better? And so for that, we've got another additional command, which is subtree import. And this lets us import external branches from some other repository, like maybe an upstream Git repository that we're vendoring, into the monorepo. And we add the additional metadata that lets us remember the fact that we vendored and do things based on that. So this is actually quite similar to Git subtree. So if you've used Git subtree, the concept isn't new, that kind of already exists. It's just slightly different and has the advantage of the features of the other commands that I just mentioned. So this works something like this. You subtree import from some URL, a particular commit, and to a particular destination path in your monorepo, and it copies just the contents of that particular commit. So it doesn't copy the whole source repository; it just copies that particular commit, like Git subtree does. So your commit history still remains linear. This is just an ordinary commit, but we keep that edge, that orange dotted line that says this directory was imported from this other source location. And now, the other tooling, like blame and log, as long as it's got that repository available somewhere, like in a local cache or something, it can now go and blend together the history of that other repository with the history of the current repository. And so blame and log still work. And you can graft and merge changes from the upstream repository. So say the upstream release a bug fix, and you want that bug fix, you just pull in the upstream repository and then subtree graft that change over to your monorepo copy of the same repository. So, as I say, we implemented this at Meta. We've been using it now for a little while. And I want to sort of share some of the feedback that we've got from some of our users about how they found this to be useful. One of the big things we weren't really kind of expecting, but came out of this is users reported being able to actually use this to control their CI costs. Like one of the problems, if you're a fundamental library with many, many dependencies in the monorepo, you make a change to your code, and now all of your dependents will try and run their tests as part of the CI, which is way too much for you to actually do reasonably in a CI system. And so by separating out dev and stable to separate branches, and then configuring exactly which of your customers are, I guess, the most important ones to not break, you can control exactly what CI runs when you make a change. It also freed people up to do more experimental things. So if you are worried about breaking some of your downstream dependencies, maybe you won't make some changes. But with a separate branch, you can safely experiment and have a throwaway branch. Maybe even you can actually just delete a directory if an experiment doesn't work out. And then. Yeah, the other example is exactly what we were saying about the vendoring case. Like people found this is very useful for migrating external repositories into the monorepo. Is either vendoring something, or also in the case of teams that were using a separate repository and now wanted to be in the monorepo, they were able to migrate more seamlessly by using the subtree import tooling. And one, I guess, kind of novel approach that we didn't really think of when we first designed it, but it sort of shows the power of building things out of tools out of small components, is some teams actually started to use it as a combined approach. So they would make a release branch, like a full repository branch, a normal branch, which obviously freezes everything. So it gives them kind of a stable base where the monorepo isn't moving forwards. But then they can use a directory branch to catch up specific things from the main branch. So they can just merge things, individual directories in from the main branch. So how does this apply to Git? Because obviously we use Sapling at Meta for this, and this is something that we've implemented in Sapling. But I don't think there's anything Sapling specific about the concept. And in fact, as I mentioned earlier, Sapling has got Git support. Like you can run Sapling on Git repositories and it'll just work. And that includes these commands. Now, obviously, it doesn't integrate with existing Git stuff, so other Git tools will just see it as a commit that adds a bunch of files. It won't have the extra metadata, it won't interpret the extra metadata. But you can try it out if you want to. It's not. We focus obviously on implementing it for Sapling repositories, so we haven't tested it thoroughly with Git, but it should work. But if you wanted to implement this in Git itself, then actually I think Git subtree is a kind of a good starting point. I think you can enhance Git subtree to store additional metadata and then do these operations. So, I mean, just to describe exactly what we do, because it's actually pretty simple. When you create these subtree copy or merge operations, you just store some additional metadata, either in the headers or somewhere in the commit message, maybe, just saying where the data came from, like where else in the repository, or in the case of imports, what other repository it came from. And then when you're running log or blame operations, if you reach the kind of beginning of history of a file, follow the merge edge, or follow the subtree operation edge. So when you get to the start of the stable history, you just look at the metadata and then follow it from there. And then the other one that's maybe the most complex one is common ancestor. So if you want to do three-way merge with across directory branches, you need to enhance your common ancestor finding function to work across directories as well. Again, following the same metadata. So the common ancestor of two files, one in the dev directory and one in the stable directory, can actually be one of a single file in the dev directory. And so you can now do a three-way merge across those. So yes, I think this is an interesting thing from the perspective. I think this is a useful tool that anyone who's using a monorepo might want to consider. Like, is this something that would be useful for them if they have the same problem in the monorepo that we do? But also, I like to think that one other aspect of it as well is I think this shows the advantages of actually improving the usability of the tool by improving what users are already doing, like finding out patterns that users are using, maybe struggling with in their implementation of in their how they're using their source control tooling, and then really meeting them where they are and developing features that make their lives easier. So if you're interested in sapling, you can find out more at Sapling SEM. We'll be writing more on this topic in the next couple of months at the Meta Engineering blog, if you want to read about it then as well. I think we'll also possibly, a bunch of us are going to Git merge, so we'll probably be talking about it there as well. So yeah, any questions?
So I'm curious, in Sapling, where do you actually store the metadata?
Yeah. So Sapling's based on the Mercurial data format. So Sapling's own format is the Mercurial data format. And Mercurial has a concept called an extra. So you can, there's basically another field in the commit object, which is a key value store. And so we use a key of subtree, and then the value is just a JSON blob saying exactly where things came from. So for the Git backend, we store that in an extra header. So we just put an extra header in the commit. But obviously that has the downsides of extra headers being like, if something else changes it, we lose the metadata. So, yeah.
How do you present to the user what branches are synced to what versions?
So when you're looking at, there's a command you can run on subtree inspect, which will just show you like in a particular commit what subtree operations there were. But also when you're looking at the history of a file, like say for example, if you're blaming a file, you want to see the history of that, we show the path of the file as part of blame. Like it's the same as if you've got a copy of the file, that blame still works across copies. It's essentially the same user interface as that, so users can see that the file came from a particular path. It works better, I think, in our sort of web-based code viewing, where you can actually see like more rich information about the history of a file. It just shows it at a different path.
You store the subtree import metadata that way as well, like where it came from and what hash it was when you imported it?
Yeah. So you saw the URL of the repo of the remote that it came from, and then because it works better, I think, in a corporate setting because they all come from our internal server, so it's generally easy to find things. We'll probably you'd probably want to implement some kind of mapping so that if the metadata is wrong, you can fix it up later if the repo's moved or something. But it degrades okay if the origin repo isn't there or isn't available, then it just degrades to what it was before. So there was no import at all.
How do users know, or users of the library, whatever that they're vendoring, how do they know when there's something upstream? Like, is it just internal communications that are like, we did a bug fix, so the 100 projects that have vendored this at various versions should probably try to update it?
So it depends on what your workflow is. It's sort of up to the team as to how they manage it. So in the case of like a widely used library, they'll have the dependencies that everyone else will take will be on the stable branch, and so they're kind of the dependencies that they have in their buck files or Bazel files, whatever, point at the stable branch. And so then it's up to the team that own the library as to when they do those releases. So they can choose if there's a bug fix they need to get out to everybody, they can just cherry pick that change across to the stable directory. And then the sort of the monorepo behavior kicks in again, and everyone just gets it because that's the latest version of the code.
But they do have to import that, or they have to.
So this is within the monorepo, so not the import case, but like the kind of two directories in the monorepo. They just make that change and land it as a separate commit. Yeah.
Yeah, maybe I'm not understanding this last question, or maybe this helps. But are there controls over whether people can base their dependency on the experimental branch instead of on like the monorepo mainline?
Yeah, so there aren't anything specific to directory branching. I mean, Buck, I think Bazel has it as well, but Buck has the idea of visibility, so you can say like these rules are only visible to certain other rules. So if you want to prevent other people depending on your dev branch, then you can make your dev branch only visible to your test suite or something. Like you can say the dev branch is only visible to tests. And then other things like that. With the Buck rules, the Buck config modifiers go via a Buck alias, so you can have a dependency where people can depend on like whichever one is selected, and the default one is the stable branch, and then it's up to the user to control it, or you can use visibility to prevent people from directly depending on the dev branch.